everybody, hi, yo, what's up? Hey, Mike here. We're going to talk today about current. Been doing a lot of talking about voltage, but not current. And so current is the flow of charge per time. And so it has the standard unit of amperes, or you might hear it colloquially referred to as amps. Those are the same amps that are in your circuit box in your basement or whatever, and you go and you look and there's breaker boxes, you know, one's 15, oven might have 230s. Those are amperes. All right. Now, the thing that's kind of confusing, it's kind of like density. You got to remember, or molarity, you got to remember that's a complex unit. So as soon as you see in solving problems, as soon as you see the current in amperes, you should just switch that to coulombs per second, okay? So an ampere is just a coulomb per second, and there are 96,500 coulombs. Coulomb is charge in a mole of electrons. That's how we're going to switch back and forth between masses of things and the current. And so this is called the Faraday constant if you want to be fancy about it. If you're an equation person, you could say, well, Q equals current times time. Quite often you see the capacity of batteries in milliamp hours. So that's actually a measure of charge of the battery. But when you do solve these problems, you got to make sure that the units match. So when you're doing a solution to a problem, like the one we're going to try in about 14 seconds, you know, if you got this in coulombs per second, your time has got to be in seconds. That's the one trick. And then you get coulombs. You can convert coulombs to moles of electrons. Let's solve a problem using current right now. It was longer than 14 seconds. I guessed wrong. Okay, let's do something with a current time problem. Here's a problem. How long would it take to deposit 1.2 grams of nickel from nickel sulfate if a current of 1.5 amperes is applied? So what someone would do is have some sort of electrode or electrically conducting material that you would put in a solution. You would pass a current through that and you would nickel plate the thing. And nickel plating is a very common thing. Let's make it a nice peaceful example, like bicycle chains, all right? But you got to kind of read through these like you're a computer, and you got to say, hey, look, okay, I ain't having any of this amperes. I got to write down this coulombs per second. 1.5 coulombs per second. It's kind of a high current, but all right. How long? That looks like I'm going to have to find seconds. The only thing I'm missing is I don't have the number of moles of electrons, but I could get there from 1.2 grams of nickel. So it looks like the place to start is not here because we don't have time. I'm going to go ahead and do some good old Gen Chem 1, and we're going to convert nickel to moles of nickel, and then to moles of electrons, and then probably the thing that you need to know is how many electrons are in the transfer as it deposits. So this is nickel 2 plus, because you have to remember your Gen Chem 1, that's what's in nickel sulfate, plus 2 electrons goes to make nickel metal. Most of the time when you are doing electroplating like this, you're reducing things to protect something that's conductive. All right, so let's go and crunch some numbers. Okay, here we are. We decided that we would run into a dead end if we used the current first, and we would have because we don't have the time. So we start with the other thing, and sometimes, folks, it's okay to start in one place and come to a dead end. Start with the other piece of information, which I could certainly find out. We know back from good old Gen Chem 1, 1 mole of nickel is 58.69 grams. Here's the trick. All these are going to be different, but here's where they're going to be different. 1 mole of nickel from above here, 2 moles of electrons. And then the last step, 1 mole of electrons is 96,000 Faraday constant, 500 coulombs. All right. Let's crank out a number for that. All right, so our answer would be 3,000. We'll worry about significant figures later, okay? So 3,946 coulombs. Okay. Now, if you like, the Q equals I times T, I'm a converter, folks. I like to convert, and I know that 1.5 amperes means 1.5 coulombs is a second. So I use my current. I used upside down current to cancel units of coulombs out. And so what I'm going to end up getting is maybe a clumsy number until I convert it to minutes. 2,631. Technically we're right. Didn't say what units. Part of me wants to make this more relatable though and divide by 60. 43, 44, 43.8, which, 44 minutes. That's how long that would take. Let's dream up one more and then we're going to set you free. Okay, here's a cute one I copied out of an old textbook. Don't say which one because I don't want to get sued. Hey, so electrolysis of, that's aluminum oxide. Now, this is actually how you make aluminum, is that you basically electrolyze molten bauxite, which is a mineral. The reason we recycle aluminum is not because it's rare. Actually, 8% of the crust of the earth is aluminum, but it takes a hell of a lot of energy to produce it. So look at that amperage right there. All right. Now, by the way, I'm not even going to use, we're going to try to find out what mass. Okay, bang. That's going to come from moles of electrons. You do got to remember what that charge is? That's aluminum 3+. So what you got to do with these problems is you first got to say, what is the reaction, requiring electrons, and you need a 3 electron transfer to plate out aluminum. So you got that going on. I don't even need the voltage. That's just trivia that was thrown in there. Here's amperage. I'm going to call that a coulomb per second. All right, so then a coulombs per second. Where do I start? I need time. I got current. I got time. What I need to do next is convert 24 hours to seconds. I think you guys probably don't need to know those conversion factors, but I'll go through it with you here. So, okay, I'm going to start with the time, multiply it times the current in coulombs per second, and hopefully get my moles of electrons that way. So it's a switcheroo from the last one. All right, 24 hours. And then 1 hour, there's 60 minutes. Hope I'm not losing anybody here. 1 minute, 60 seconds. 1 second, 1.0 times 10 to the 5. That's a huge current, guys. Coulombs. I spazzed out there. That will be our charge in coulombs. Holy cannoli. 8.6 million coulombs. All right. So let's go start with that now. So we're going to start over here with 8.64 times 10 to the 9 coulombs. There are 96,500 coulombs, 1 mole of electrons. All right, got to remember our original transfer. Okay, so There are 3 moles of electrons in 1 mole of aluminum. Oh, I can smell it. We're almost there. 1 mole of aluminum is 26.98 grams. It's going to be a huge number. Probably want to convert it to kilograms. Okay, hold on. By the way, I misspoke earlier. I said 8.6 million. That's 8.6 billion. This is in the millions. 2.41 times 10 to the 6th grams. Or, let's make it more relatable. 2.41 times 10 to the 3 kilograms. 1 kilogram. I know I didn't have to go any further. Just said what mass. I could have quit right there, but I'm dedicated, y'all. 5,300 and let's see, everything was in 2 digits. 5,300 pounds. All right, check myself before I wreck myself. Coulombs cancel coulombs. Moles of electrons cancel moles of electrons. Moles of aluminum, grams, divided by 1,000 to get kilograms. 2.2 pounds is a kilogram, because that's that little teeny weeny plate you put at the end when you're trying to max out at bench press, trying to just goose yourself up past your personal record. And I'm sorry, now I'm rambling, but you guys get it. That's what it all is dissecting what's given. It's all unit conversion. Next, we'll talk about balancing redox equations. Until then, take care of yourself, stop the spread, be nice to each other, be kind, rewind. So long.